Greg Schmergel and Keshav Singh don't claim to have found the fountain of youth, but by founding Yuva Biosciences, they do intend to extend the health span. In other words, the length of time that people are leading healthy, energetic lives. Their approach is to target aging and age related diseases through innovative mitochondrial science. The first products are meant to address wrinkles and hair loss. After that, it's on to ovarian aging and reproductive health. I'm David Williams, host of the Health Biz podcast and president of Health Business Group, a strategy consulting firm that helps healthcare and life sciences companies like Yuva develop robust growth plans. Reach out to me, dwilliams at healthbusinessgroup.com, if you'd like to discuss strategy for your company. And finally, please do me a favor and subscribe to the podcast. So it's good to have both of you here. And I want to talk about what the company's doing because it's really fascinating. Although I guess I'll have all the time in the world since they're going to cure aging, and we'll be able to listen to podcasts endlessly. I guess that'll be one of the advantages. But before we do that, would love to hear a little bit about kind of your upbringing and any childhood influences and education. Maybe I'll let you go one at a time, considering that I assume those were different.
Sure. Yeah, I can go first. My upbringing was in an entrepreneurial family. And in fact, our family has a history of entrepreneurship going back a couple hundred years. And my father actually was the first CEO of one of the major biotech companies back in the 1980s when biotech was just getting started, Genetics Institute. And he left Baxter Travenol and went to a small biotech startup back when that was a risky and unknown thing to get involved in this new industry that was just getting started. So I got to watch that grow from just him and a couple scientists to 1,000 people, and eventually he did an IPO, and then the company was bought, and it was an amazing journey. So I was not pushed to become an entrepreneur, but saw it every day growing up, and including with my grandfather. And so it was natural that I went into entrepreneurship after college. In college, I actually majored in international relations to do something different because I knew, after college I would be going into business. So I figured let's do something different in college and before the rest of my life starts. And then I've started 4 companies now, all in different fields of technology. So nanotechnology, research services for technology, and an internet company, and then ended up meeting Keshav. So I'll turn it over to Keshav for his background before we get into how we met.
Yeah. Well, so I had actually multiple influences from my father and mother. My father did a degree in agriculture, but he ran railways in India. And something I learned, and actually one thing I coined the term because I didn't quite know what he was saying at the time. He said, whatever you do, you have to do the best. That sounds simple. And then he will say, you know what? If you want to be really a bad guy, you better be a bad guy.
Yeah,
that police can't catch you.
Yeah.
Yeah, worst bad guy. That sort of it stuck with me, and I said, what? So then I coined the term was called successfully fail. So my motto became, again, what I do, I had to do, and if I fail, but I tried my best. And that led to me actually a couple of things. So I was one of those people who are the youngest in the family. My brother was a engineer. My sister was an engineer. My other sister was an artist. And there was a little pressure that, you want to be a doctor. So I became a different kind of a doctor. And that led me to do a microbiology degree in India. Then it led to go to Australia and marine biology. At the time I was interested, came to Woodsole. And that time when I came to Woodsole, I worked at MIT, and I fell in love with the Boston area, how much, it's like a science festival every day. Went back, did my PhD, and came as a postdoc at Harvard. But I like new things, and my father actually again reminds me. So he learned to ride a motorbike as age 85.
Wow.
So
I'm going to stay out of the way
Yeah,
though.
because
No offense. Yeah.
well, he got tired of the driver he had because the driver would call sick
Yeah.
whenever he wanted to go and say, "Hell with it, I'm going to ride the motorbike," and he did pretty well.
Good.
He wouldn't go a long distance.
No. I think it's great to pick up new skills. All right. So now I got to hear how you met.
So actually, I
Really?
read I think one of the hundreds of stories about Keshav's one of Keshav's many discoveries, but one of them was a couple of years ago when he became the first person to demonstrate the causal link between mitochondrial dysfunction and hair loss and skin aging, demonstrated in the mouse model that he developed over 9+ years of work at UAB. And that work was so fascinating to the world that it was published in or covered in publications in over 100 different languages, ranging and published in publications ranging from business publications to USA Today to Vogue and Cosmopolitan and just about every kind of publication. So I saw one of those and was fascinated by the work and reached out and managed to get in touch with Keshav and proposed that we start a company, given that there is a tremendous market for not only the long-term vision of slowing down the aging process, but also the shorter-term potential for products that can prevent and reverse hair loss and skin aging in humans.
The Keshav, does that line up with your story, or do you have like a different origin story?
No, it's the same story. Actually, at the time, when obviously when we got a lot of publicity, I wanted to start a startup. Actually, I presented it to actually Y Combinator. They contacted us there, but I wasn't going to go that route because it's a very complicated, long drawn process. And when Greg contacted, I was ready to jump on it and start.
Yeah. Well, that sounds good. So Greg was kind enough to walk me through what you're doing before, so I have some ideas and some questions for you. And one is just about, what is the role of mitochondria in aging, and what's the relationship to, other hallmarks of aging? I understand mitochondria changes, but there's a lot of other changes that go on as well. So what's the role there, and how does it relate to everything else?
Yeah, so mitochondria are one of the hallmark of aging. There are 9 hallmarks of the aging, and as we know, I think everybody experiences that as we age, we don't have energy, and that is because of mitochondria are the powerhouse of the cell. But that's not the only thing mitochondria do. They do multiple functions in the cell and in the organ and in the whole body. So and what we have found, actually, we published many of the articles relating the mitochondrial function or dysfunction to other hallmarks of aging. For example, we shown actually in 1999 that mitochondrial dysfunction leads to genomic instability, which is another hallmark. It leads to epigenetic changes. It leads to intercellular crosstalk differences. So about 7 of those hallmarks are connected with mitochondrial function. So for us, this is the foundational problem appears to be during the process of aging, and we should do something about it.
When you look at this, I saw these different hallmarks, and I won't say it's depressing, but I'm looking for a hallmark there like greater wisdom or perspective on life or something like that. But I guess you get that too, but it's not it doesn't cancel out all these other things.
Mhm.
So now the thing is that's good about this, I think people have heard of mitochondria, and also it's not the first time that people have thought about how do you make an impact, and what does that mean kind of from a product and commercial standpoint. And I think that's important when you talk about sort of the long road to go from that insight that you have into actually changing people's lives, certainly on the hair and the skin, but never mind some of the broader things that you have in mind. Have mitochondrial insights and innovations actually been leveraged before in the direct-to-consumer market and prescription products, or would you be the first one?
So there have been attempts in the past, and that were by mostly looking at mitochondrial diseases. So there are companies who targeted at first. Actually, let me tell you. So We started this ground foundational work in 1999, where I've been working with United Mitochondrial Disease Foundation for almost 25 years now. So there are a set of mitochondrial diseases where primary defect in mitochondria leads to those diseases, and many of them multi-system disorders. So so we came up with the definition. There is still no clinical standard for the diagnosis of disease. So there were companies, but it's so heterogeneous and complex in the context of the mitochondrial diseases. So that is still going on. There were a couple companies who didn't succeed because their approaches were different. Our approach is, and the platform we have developed, I can describe to you in a minute, but something we can switch on and off, and then go after it. What happens when you switch off and switch on, and when you switch off, the things revert. And obviously, that gives us the big handle to find out what's really happening and how to be targeted.
Great. So maybe you can explain a little bit about the platform and what it means to sort of be able to switch things on and off, how that's done, and then what you do with such a platform.
Yeah, so what we developed was a mouse platform, mouse model, where we can take advantage of the previous experience we had in the field looking at cancer. And so what we found was there was a mutation in a gene called polymerase gamma that leads to the depletion of mitochondrial DNA. So we hooked that up with a GFP, green fluorescent protein, which is what we call bicistronic. So wherever this gene is expressed, the GFP would be expressed, and we can turn on by giving doxycycline. So when doxycycline is given, it will disrupt mitochondrial function because the dominant negative polymerase gamma is turned on. Now we take away doxycycline, it will come back. So that's the approach we have taken. And that disruption, even though at the genetic level, that recapitulate what you see during the process of aging. People lose their mitochondrial DNA over time.
And, obviously a mouse is not a person. Animal models sometimes work great, and sometimes it turns out the animal is one thing and the person is something completely different. Why would you use the mouse, and what's your level of confidence, and what are the kind of the open questions about how it would apply in a person?
Well, so we have a great degree of confidence. And in fact, I am a co-director of a course called Genetic Model of Human Disease. And I gave a lecture just yesterday on aging related models. So from yeast to humans, in between the C. elegans, which is the worm, mice, zebrafish, there are many of these pathways are conserved, and that's where we fit in. Because if you will find literature using Baker's yeast or C. elegans, you disrupt mitochondrial function, you can see that there is signature aging problem in those model system too.
So it's good to know. I guess I've gotten used to the idea of being compared to a mouse. I've never been compared to a yeast before, but I suppose it's good to know we all have something in common. Now, okay, great. So that sounds terrific, and I think everybody hopes that it will work. Talk about the application. I mean, Greg, up front, one of the things that you said you were excited about this. This is the fountain of youth, but perhaps in our lifetimes. In other words, there's some things that could actually be on the market sooner rather than later, and I like that too when you described it to me. So, can you talk about where it's being applied, and maybe talk about some of these things that have a shorter pathway first, and what those are, and why you picked them?
Sure, definitely. So we did. Obviously, we see the long-term potential for improving mitochondrial function and affecting aging itself, but that is a longer-term project. So, as you said, we did pick several indications that are shorter term and much shorter term. So the shortest term, of course, are hair and skin, and those are, of course, much simpler parts of the body, and also parts where you can affect them with a topical application. And there are also parts where, again, a mouse model is much more correlated to humans than in other organs, which are more complex. So that's another positive. And then another positive that makes it a potentially much shorter term application is that Keshav has already discovered multiple natural compounds that can improve mitochondrial function. and that have been tested in the mouse model now, that have been tested in vitro in our Yuva Biosciences lab in Birmingham, Alabama, and have also now entered into human trials already on a much more accelerated basis, again, than would be possible with other indications. And given that the compounds that we're testing now are natural, so for example, botanical extracts, it's possible for them to go to market, without FDA approval. They have a long history of safety and therefore can go to market in a much shorter time frame. And then as the third indication after that, we've picked ovarian aging, which is one that Keshav has already been doing a lot of work on and has published several papers on, and that we believe the same compounds that we are discovering for hair and skin can also have an effect in slowing down ovarian aging and thus extending fertility, as well as alleviating the symptoms of menopause, for example.
So on these first products for the hair and the skin, I understand the regulatory pathway is more straightforward. Is there the possibility for intellectual property protection there, or is it just you're saying, hey, you're telling people there's this product on the market already, and it happens to actually work because of the way because of its mechanism of action, and go ahead and use it? What's the kind of the business side of that?
Sure, absolutely. So it's an area where of course you cannot own a plant or its extract, but you can, and companies have filed many thousands of patents in this area, not on what we're doing, but in the area of patenting natural products. And the way that they do it, and that we plan to do it as well, is to patent around the plant. So patent methods of use and treatment, patent methods of synthesis, methods of purification, combinations and formulations of the compound, combinations of the compound with other compounds. So there's a whole fortress that can be built around the product, even though you can't own the molecules themselves the way you can if you develop your own new molecule. So it's something that, again, has a long history. For decades. Companies have filed, again, thousands, if not tens of thousands, of patents around natural products. And if you look at cosmetics companies, for example, or cosmeceutical companies, they have many thousands of patents each, many of which do cover natural compounds.
I thought what you're doing on the area of ovarian aging is very interesting. Partly, my first thought was it was about about reproductive health and extending that. But you mentioned that it seems as though menopause is an undertreated area, and there's a lot of people that that could use some help there. Can you say a little bit more about sort of that as an area of focus, and what the hope might be here, and what's the pathway for this one in terms of development and regulatory?
Sure. So I'll let Keshav talk about the science in a minute, but on the business side, it's definitely an underserved area. So there has been given that women are a little over half the population, there's been a shocking lack of companies going after innovative new methods to treat menopause symptoms and to alleviate some of the issues that come with ovarian aging, like premature menopause, like a premature ovarian insufficiency, and issues like that are very serious and cause substantial medical, psychological, financial issues for women and for society. But when you look at the number of startups that are taking new approaches and trying to develop products for the market, it's shockingly low. And we believe that in the area of applying mitochondrial science to this area, that we're the first. We probably won't be the only one for long, but because we do think it's a highly promising pathway to take. But we're the first and hope to have the best treatments available. So Keshav can talk more about the science and the work that he's done to show the linkage between mitochondrial function and ovarian aging.
That's sure. So in the same platform which we have developed, where we can knock down mitochondrial function and we can restore it, we targeted ovarian function. And what we found was there was a premature ovarian phenotype in these mice. So they seem to recapitulate what you see in women. So, for example, AMH, which is anti-Mullerian hormone, that goes down when women go through menopause. You also see what's called vaginal atrophy, where the epithelial cells of the vagina become thinner, and that leads to many problems related to sexual intercourse and other aspect of the menopause related function. But more importantly, it can extend. So these mice, when they have mitochondrial dysfunction and leads to ovarian problem, they are infertile. So our goal is to whatever we develop, we can extend the reproductive health of the woman using this approach we have. And obviously, we're going to take an approach where first thing is looking at FDA approved drugs. So we screen them, look at which one is functions best, and that will be the clinical and preclinical approaches we will take.
Well, it sounds very exciting. And who wouldn't try a little bit of cream to see how it's working or not? But what are the kind of questions that come up on areas of efficacy and safety? I mean, I guess the first thing from a layperson standpoint is you think, well, aging is a natural process, and when you start to disrupt it by changing one thing, are you going to somehow introduce more of a chance to get cancer or some other kinds of problems that are hard to see for now? And it's one thing to use a cream, but it's another thing, for some of these more systemic approaches that you're taking. How do you think about that, and what's the pathway?
So one thing I do want to emphasize that we are not extending life. We are not about longevity per se. We are about the health span. So it's not the lifespan we are targeting. We are targeting the health span. So people live long enough, and obviously during the process of aging, the health deteriorates. There are many aging-associated diseases. So that's where we are targeting to improve the health.
And I think that the mechanism of action of the products that we're targeting for all the indications is the same mechanism of action, which is improving mitochondrial function. And that means that the mitochondria will be able to generate more energy for the cells to do what they're supposed to be doing. And as Keshav noted earlier, as we age, that starts to deteriorate. And it's a positive, for multiple tissues in the body to have improved mitochondrial function and have more energy to, again, do what they're supposed to be doing. So we're not, changing, introducing major changes to how the body operates, but rather improving how it should be operating and how the mitochondria should be operating.
It's more like a restorative therapy. So what is lost can be regained. And when we did this experiment and the paper we published where we disrupted the mitochondrial function, you see the skin wrinkle and loss of hair. When the mitochondrial function was regained, things came back. The hair came back, the wrinkles were gone. So we are trying to regain what is lost in terms of the mitochondrial function.
So you'll find, for example, just maybe simplistic, and maybe this doesn't fit, but sometimes when people have any kind of a serious illness, they may have hair loss as part of that, and when they feel better, when they start to get better, it's often restored. And it sounds like what you're talking about is allowing people to regain kind of their potential. It's something that they're maybe losing as they age, to be able to restore what they're capable of already. It's not some sort of superhuman power. So as if you think about sort of traditional thinking about the fountain of youth, it might be like, youthfulness forever. And what you're talking about when you're talking about the health span is to say, the ages people are living to are already pretty good. 80, 90 is happening. And now they're going to be able to live that life in a way that's going to be, when they're 90, it's more like they're 50 than like they're really kind of expiring, if I understand it.
So I was saying that the trademark that we've registered is youthfulness for life. So it's not live forever, but it's youthfulness for life.
Good. All right. So how are you funding the company up until this point? You mentioned it's a hot area, and certainly I can understand why that would be the case. What sort of investor does this attract?
Mm-hmm. Yeah, so we've been funding the company so far from seed stage VCs and angels and angel groups. So we initially targeted $1 million for the pre-seed round. We actually are now 2x oversubscribed at $2 million for the pre-seed round. One of the main VC funds in it is the Longevity Tech Fund, which, as its name implies, is one of the leading longevity-focused seed stage funds in the world. They're based in Europe but invest worldwide. We also have the Alabama Capital Network, since Yuva Bio is based near Keshav's lab at University of Alabama, Birmingham, just down the street at the Innovation Depot in Birmingham. So we've had fantastic support from Alabama Capital Network and local angels in Birmingham, as well as angels and angel groups in Boston as well. And I think for a lot of the, I'm based in Boston. Everybody else in the company is in Birmingham. And when I talk to investors in Boston, a lot of them only invest in Boston and Cambridge, maybe Waltham. But going further than that is often not done. And so it's for some of them it's their first investment further away. But I think it's something that, especially now in the era of video chat and communicating with people virtually anyway, I think it's opened people's minds to the fact that they can invest anywhere in the country, and that there is world-class science going on in multiple locations. And in fact, Keshav's lab and UAB in general are world leaders in life sciences research.
So obviously you'll need to go beyond the pre-seed and seed if this is going to scale up. Do you have an idea of what the trajectory looks like on both the funding side and the business side, and paint sort of as long of a time horizon as you like?
Yeah, definitely. So we're already in discussions now for the seed round to raise a couple million more, and then the goal is in 18 to 24 months to then target the Series A for $4 to $5 million at that point, which would then let us go more aggressively after ovarian aging and start thinking about additional indications after that as well. In the mitochondrial science field, given that mitochondria are so critical for the function of every part of the body, there's almost too much choice as to which indications to go after next. So we have to be very careful in picking the ones where the scientific linkage is the strongest, and where the path to market is the shortest and most reliable. So Keshav's expertise has been critical to helping get that done and get us a development plan that makes the most sense for us and for our investors.
As Greg mentioned, we have so many choices to go after. Obviously, we have to focus. But one thing in that context I want to bring up is that in December 2nd and 3rd, I'm one of the organizers of the conference where we're talking about mitochondria as a driver of COVID to cosmos. So what is turning out to be that cross-species studies which have been done on International Space Station, including the astronaut, they seem to develop mitochondrial dysfunction. So NASA and NIH, 6 different institutes, and me, we put together a really good team to think about countermeasures to these problems. So I think for me, the sky is the limit, but at the moment we have to focus on what we can deliver quickly.
Well, it sounds like not even the sky is the limit if you're going to go to the space station and low Earth orbit, if that's above the sky, or maybe that's included.
We have published a paper, very significant paper, which has been downloaded 22,000 times, regards to COVID-19 hijacking of mitochondria and how that leading to chronic fatigue. So 58% of the long haulers are experiencing chronic fatigue.
So it's no doubt, if people didn't care about hair and skin, we know that they care about COVID-19. So it's great that there might be some earlier applications, and certainly gives people some hope about what they might do. I want to close off by just asking you if you have time for any reading, any books that you might recommend to our listeners, or any books you recommend that they stay away from.
Well, I'll stay positive and recommend a book by one of my former professors at Harvard Business School, Clay Christensen, who was a great author and wrote a lot of iconic books about disruptive innovation. But the one that I'll recommend was a little bit different, and it's a shorter book that he wrote called "How Will You Measure Your Life?" And he wrote it to inspire people to think about not just success in the ways that people often think about it, money and status, but rather to think about your life more broadly and what you want to achieve, and when you're looking back on your life in the future, what will actually make you happy and make your family happy, and add up to success for you. And it was a fantastic book that he wrote, and that I think has inspired a lot of people.
So for me is that, believe it or not, I have not read a book. I read the abstract, the front page, the preface, and the back. I just don't have the patience, and I'm being honest with you. Okay, I'm one of those guys. I need to know everything, so I don't have to go through 500 pages of something. If I can know, within a couple of minutes. But I think I would like to write a book or successfully fail.
Yeah, good. Excellent. All right. Well, I want to say thank you, Greg Schmergel and Keshav Singh from Yuva Biosciences, for coming on Health Biz Podcast today and sharing your very positive vision for where we're going in the long term, and maybe a little sooner than that. So thank you.
Thank you.
Thank you.
You've been listening to the Health Biz Podcast with me, David Williams, president of Health Business Group. I conduct in-depth interviews with leaders in healthcare business and policy. If you like what you hear, go ahead and subscribe on your favorite service. While you're at it, go ahead and subscribe on your second and third favorite services as well. There's more good stuff to come, and you won't want to miss an episode. If your organization is seeking strategy consulting services in healthcare, check out our website, healthbusinessgroup.com.